There we go. All right, so we're going to be talking about states of matter or phases of matter first, and then we're going to get to physical and chemical properties. And then if you guys are participating and we're moving at a good pace, we should get to phase changes today. And so that'd be good. And we're probably not going to have homework just yet, because I want us to get a good bit of material, and then we'll eventually have a homework quiz probably on Tuesday. Okay. So I'm going to share my screen as soon as I figure out where it is again. Share screen, whiteboard. All right, I'm getting used to writing on this whiteboard, so you got to bear with me because sometimes it is bad. My writing looks really bad anyway. All right. Oops. See, I'm already writing. All right, everybody ready with their notes, hopefully. Here we go. This is just so I can make sure you guys are seeing what I'm seeing. All right, so we're going to start out with the states of matter. States of matter. Okay, so we call them states of matter. So sometimes we call them states of matter or phases, either way. All right, so let me, I want to be able to see people's names. All right, Elizabeth, give me one of these states of matter, please. Elizabeth, are you there? Hopefully I got my message yesterday about it here. Are you in the chat, Elizabeth? No? All right, Daniela, can you give me one of the states of matter?
Liquid.
Yes, liquid. Thank you very much. Liquid. Jermaine, can you give me another one?
Solid.
Solid. Very nice. Camille, what's the other one we're listing?
Gas.
Gas. Thank you. All right. So the way we tell the difference between these three states of matter, okay, is by three different things. One is shape, the other one is volume, and then the other one's going to be how their particles are set up. So I'm going to write that down the side. You can do it however you want. You don't even have to write it on the side if you don't want to. But so one way we tell the difference between a solid, liquid, gas is by the shape. I'm going to write it sideways here. Oops. Shape, and then volume, and then the particles. Anybody remember what the particles are called? They're tiny particles, and it starts with an A. Anybody remember what those are called?
Atoms.
Atoms. Thank you very much. They're called atoms. All right. Does anybody have a preference, like the way you think? Should I do everything for solid first, then liquid, then gas? Or do you want me to do the shapes all the way across, solid, liquid, gas, then the volume, then the gas? Anybody have a preference?
It doesn't matter. You can do it either
I'd
way.
prefer doing solids, liquids, then gas.
Okay, so you prefer going all the way down first?
Yes,
It doesn't
ma'am.
really matter to me.
Okay, that's fine. If it helps at least one person, then I think for most people it doesn't matter, but if it helps somebody, then I'll go that way. So we'll go all the way down. All right, so that was Julie that just popped in. Did somebody else just pop in? Just Julie. Oh, and Tyson. All right, so we're gonna start with solid first. All right, so for a solid, here is my mouse, okay? The shape. So when we're talking about the shape and the volume, we're asking, is it defined or is it undefined? Okay, so defined meaning I can't change it. Undefined meaning, oh, okay, it can kind of take the shape of this container or it can change, okay? So a solid, this is my mouse. I cannot do anything to this to make it change one way or another. So we're gonna say that this has a defined shape. So, okay, so this is defined and it's not writing. Oop, there we go. Right. So solids have a defined shape. There's nothing about them that can change, okay? What about the volume? So volume is just telling you how much space do you take up, okay? So I have my shape, but how much space am I taking up? So this mouse,
Doesn't it?
go ahead. No, go ahead.
Doesn't it take up like the space that it's in?
It does take
It
up the
takes
space.
up the shape of the like the like say for so like that video we watched yesterday, if it's in like a cylinder like ice, it'll take up the shape of the object that it's in. So it'll
Now
take
that's
up-
a good point. Okay, so like you said, ice. Now, is ice though going to take up the entire shape of a cup, or is it still kind of like if you have like the crushed ice, do those cubes now like flatten out in their container, or are they still like cubes?
they're still cubes.
They're still cubes, so they're not really going to take the shape of their container. Like for instance, I can't if I put this mouse into my coffee cup, it still would take up the same amount of space. It can't spread out or take up less space than what it's already taken up. So that's how we define that. When we say define, it's like, can you take up more space or less space than you should? And for a volume, for a solid, it's not. Whatever amount of space it takes up, it's going to continue to take it up. So we're going to say that this one is defined as well. Okay. And if you want to make a note of what volume is, remember it is much space you take up, okay? I'm trying to shorthand there, but how much space you take up. All right. All right, so we said that the shape for a solid is defined, okay? Meaning you can't change it. So there's a reason why we can't change the shape of a solid. So if I were to zoom in, remember we said atoms are super, super, super tiny. We can't see them with our regular eyes, right? We need like a super duper, 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 duper microscope, right? But if I took and looked at just one little piece of that mouse zoomed in, so I'm gonna pretend I'm zooming in, here's a zoomed in, all right? And I'm gonna eventually do a zoomed in for all of these, right? And we're gonna look at how they look different, okay? I'm just gonna pretend that I'm looking at 10 atoms, okay? If I looked at those, what do you think the atoms in a solid look like?
They're stuck together.
They're stuck together. They are super tight together. They're like, it's like if there was like 500 people in this room. And actually they're moving, but it's so many, they're so close up on each other that you can't tell. They're just kind of like this, okay? So we kind of actually say that they're vibrating in place, but if I were to draw 10 of them, they would be like right up on each other. Let me do another color here. They would be like right up on each other. 1, 2, and they're probably even closer than this, right? But if I put them closer, they're just gonna kind of run together. 3, what's that? 5, 6, 7, 8, 9, 10. I'm just gonna draw 10, okay? So they are very, very close together. That says close. I know my writing's horrible. Oops. Okay. Very close together. All right. And remember I said they are actually moving. You just can't tell. We're going to say that they vibrate in place. Okay. They vibrate in place. So that's all they can do, right? If I had 20 people standing right next to me right now in this camera, it's like, excuse me. There's really nowhere to go, okay? All right, so that's a solid. Define shape, shape's not gonna change. Define volume, however much space it takes up, that's how much space it takes up. And those particles are super, super, super close together. Now I just wanna say, I drew 10, but realistically, like that whole circle would be filled up, right? But those dots would just be up on each other, okay? Now, a liquid, on the other hand, okay? So I think that was Mariah that was talking about when you put stuff in different containers. Okay. So let's say I have coffee, okay, which I do in this cup. But let's say I poured it into like a beaker or even like this bottle, okay? The shape of my coffee is taking the shape of this container, right? If I poured it in here, would it take the shape of this container? I would think,
Yes.
yep, I would think it would. So in that case, the shape of the liquid can change, okay? It can change. So I'm gonna write this 2 different ways, and it's only so that if you see it on a quiz or a test, that you know they mean the same thing. So I can say it's undefined, okay, which just means it can change, or I can say indefinite. They both mean the same thing though. Oops. Working on my writing. I promise you my handwriting is better than this. It's not the greatest, but it's better than this. So undefined and indefinite. And then I heard someone else say, basically it takes the shape of its container, right? Takes shape of container, right? So if you remember on the video, they had the green liquid and it was like in a graduated cylinder, which looks like, you don't have to draw this, okay? I'm just showing you. But remember they had like a graduated cylinder and it had like some green liquid in there and they had the same amount. So it was like this in there. And then they poured it into a beaker that looked like this. So it was the same amount, but when they poured it in here, now it took the shape of its container. It was the same amount though, okay? So it just takes the shape of its container. All right, now volume, again, how much space does it take up? So for instance, I've got my handy dandy disinfectant spray for when everybody comes back, okay? This is a pretty full bottle, okay? If I tried to pour this bottle, okay, into something way smaller, a cup this big, okay? What's gonna happen if I keep pouring this and this cup gets full?
It's gonna overflow.
It's gonna overflow because however much space this liquid takes up, that's how much it takes up. I can't shrink it and say, okay, well, I only want you to take up enough space of this cup. It's gonna take up however much space it takes up. So this one is kind of like a solid. It is defined. Oops. I like sticking with my colors. Sorry. It is a defined volume, okay? Whatever amount of space it takes up, that's what it's taking up. I can't shrink it. I can't expand it, make it bigger, okay? All right, what do you think the particles look like in a liquid?
They would be together, but not that close.
Yeah, they're still close, but not as close as a solid, right? So they got a little bit more, we can say wiggle room or however you want to say it. So let's say we're doing our 10 dots again. So here's a dot. They might have a little bit more space. What happened to that one? Okay. What's that? 5, 6, 7, 8, 9, 10. All right, so way more spaced out. And I did not purposely draw them bigger. They're supposed to be the same size as the other ones, okay? So if you think about a liquid, let's see if I got something. No, okay, so if you think about a liquid, think about if I were to, oh, I wish I had that. Okay, if I were to pour a solid into this cup, the whole thing just goes over. But if I were to pour liquid, I'm not gonna do this because I'm still drinking this coffee. If I were to pour this, it would flow into the cup, right? That's because these particles down here, they are loosely packed. Sorry, let me go back. Loosely packed together, loosely packed together, okay? And they can slide, or let me think of another word. Glide. Anybody got any other words we could use? Float, roll, however you want to say it. They can flow, roll, slide, glide all over each other, right? But they're still connected. Okay, so that is a liquid. Now here's the good thing about when we start to try to remember these, okay? When we start to think about these and try to remember, you got a solid, it's like define, define. The liquid, one of them's undefined, one of them is defined. What do you think a gas is going to be? For about shape and volume, what do you think?
Undefined.
Undefined for both of them, actually. Yeah. All right. So for the shape, okay, I'm in this big empty room by myself. Okay, this big empty room by myself, and it is filled with a gas. What gas is it filled with? Somebody tell me.
Oxygen.
Filled with oxygen. Any other gases?
Nitrogen.
Hydrogen, nitrogen,
Hydrogen. Air. What do we breathe out? Anybody know what we breathe out?
carbon dioxide.
Carbon dioxide. Very nice. There's also nitrogen in the air. So there's air itself is a mixture of a bunch of gases. And we're going to talk about mixtures in like another week. Okay. But it's a whole bunch of gases in here. Okay. And they're taking up all this space, right? But I could take the air in this room and I could condense it. All right. I need anybody who wants to volunteer for me. It's a super easy volunteer. Give me a thumbs up if you want to volunteer. If not, I'm going to pick someone. It's super easy. I promise you.
I'll do it, I guess.
Okay. All right, Ryan. So, Ryan, I need you to tell me, when you drink a soda, when you open it, twist the top off or pop it, please tell me the sound that you hear.
It's a hiss sound.
It's a hiss sound. You got to demonstrate. You got to demonstrate.
Well, my Coke's half drinking, so it won't make the sound anymore.
I want you to demonstrate. You don't have to do it with your actual Coke.
It has like a little hiss sound when you open it.
You're not gonna demonstrate? It's a hiss sound. What's a hiss sound like?
I ain't gonna do that now. I ain't gonna go that far.
Janai, can you do the hiss sound for us?
See, I can't do that because my voice is not that up right now. So
Man, y'all are tripping. I know people can make a hiss
what
sound.
you mean we tripping? It's the truth.
See, I just made it and I was clowning y'all at the same time. Look at that. Boom. Okay.
I made the sound, but you didn't hear me.
Oh, that was you that made it. Oh, do it again, Mariah. Thank you. Yes. Okay. So when we think about a gas, okay, and the particles, the cool thing about a gas, so the shape is undefined, okay, or indefinite. It's the same as a liquid. But here's the cool thing about a gas. In there, you have these particles and they can be compressed or expanded. All right, so I'm going to tell you why I was talking about the soda, okay? When we drink a soda, that's what's inside of the soda. So, you know, notice that sodas are called carbonated drinks, okay? Because when they make them, they put carbon dioxide in them, okay? Which is a gas. We already talked about that. That's the stuff we breathe out, okay? So when they put the carbon dioxide in there, remember now, gas particles are like the party ones. They like to be very far apart. But I can take them and squeeze them into a very small space, like a can of soda, okay? But that's not how they like to be. So as soon as you open your soda, they're escaping. They're like, whoo, I'm free, and they're out again, right? So that's what you're hearing when you open your soda. It's all the gas particles that are trapped inside that tiny space escaping again. That's also how, if you've ever seen compressed air, like the cans, that's also why it's compressed air. It's air that has been put into a really small space. So compressed air, air fresheners, right? Those are gas particles. As soon as you hit the button and let them come out, they go every which way, okay? All right, so because those particles can be compressed or expanded, the shape is undefined and the amount of space they take up is also undefined, okay? So This one is also undefined. They can be squeezed into a very, very small space, or they can be free and take up a space as big as my classroom, okay? All right, so now that we've talked about that, we should know what our drawing is gonna look like, okay? These are very far apart, very far apart, all right? And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so very far apart, right? But because they have so much space, you can squeeze them together, but as soon as they get the opportunity to space back out, they are. So that's why when we open our soda, when you have compressed air, trying to think what else, anything, you blow air into a balloon, right? If you really think about it, when you blow up a balloon, you're really not blowing that much air into it, but it gets really big because those particles are like, I'm gonna go as far away from the other particles as I possibly can, okay? So here's what you need to know in case we have a quiz or when we have a quiz, okay? Here are the type of questions that I could ask you. I could say, please tell me something, tell me the state of matter that has both an undefined, why did I put a D there? Undefinite, yes, sorry. I got distracted and I got distracted again. There's an E right there. It's supposed to be an E. There we go. Okay, so I could say, please tell me who has both an undefined shape and an undefined volume. You would tell me a gas. Maybe I would ask you, tell me whose particles are typed very close together. You would tell me a solid. Whose particles, sorry, let me move this. Whose particles can slide or glide or roll past one another? You would tell me a liquid. I could say this one has a defined volume, but takes the shape of its container. That will also be a liquid. All right, any questions on states of matter or phases? I see no thumbs. I hear no unmutes. Good, okay. Anybody still writing before I go to the next slide? No unmutes, no thumbs. Okay. All right, so now we're going to talk about physical and chemical properties. And I'm being specific because later on we're going to talk about physical and chemical changes, okay? All right, here we go. Physical and chemical properties. So we're going to start with physical properties first, okay? Draw. There we go. All right, so physical properties. I'm going to put props for short because I'm lazy, okay? So we're going to talk about physical properties, and then we're going to talk about chemical properties after that. Okay, all right, so let's start talking about physical properties. So when we're talking about physical properties, what we're talking about are things that you can observe. Okay, I'm going to write this in just a second. Give me 1 second. All right, so we're talking about these are things you can observe. Okay, a lot of times with your 5 senses, I'm just going to put 5 senses right here. That's a 5 senses. And here's the key thing: without changing the substance. And when I say substance, I'm just talking about whatever you're looking at. So maybe the substance is water, maybe it is hydrochloric acid, maybe it's a notepad, maybe it's my coffee, whatever it is. Okay, so we're looking at stuff that we can change without changing, basically without changing the identity of the substance. Okay, so for example, okay, let's get one of these sheets of paper off. Oh, actually, let's do this. All
That's
right,
the definition, right, Miss Payton? That's the
yes,
definition.
ma'am. Yes, ma'am. All right, so for example, now we said using our five senses, but obviously you guys can only use one right now because you're online. But for instance, if I told you, tell me a physical property of this, these are our new hall passes, one-time use, okay? If I told you to tell me a physical property of this, what's the first thing I'm gonna ask Skylar, what's the first thing you notice about this?
It's pink.
Yes, it's pink, it's pinkish red, yes. Yes, you're right. I know it was funny in there. Kind of red, pink, okay? All right, so the first thing you notice is the color. So here is an example of a physical property, color, okay? Could anybody else tell me anything else about this?
It's rectangle.
It's a rectangle, so shape, very nice. This shape can tell you about it, all right? So anything, no matter what, if I say this is red, okay, I can note that without doing anything to it. It's a rectangle. I can note that without doing anything to it.
Well, we can't feel it, but couldn't we say like how it feels?
Yes, very nice. Thank you. Okay, so the texture, you could tell me it's nice and smooth, okay? Or if it was rough, you could tell me that. So texture, color, shape. I'm going to tell you a couple that you would have to be touching it to do it, but it's not going to change the fact that this is still a notepad of hall passes, okay? You could tell me what the mass of it is, okay? I have to do something to it, but once I put it on the balance and it tells me it's still, I got another one. It's still a notepad, okay? I dropped the other one. But you could tell me the mass. What about the other thing that means how much space it takes up?
Volume.
Volume. You can also tell me the volume of it. Very nice. And then does anybody remember from the video that one thing they talked about, which tells you like, oh, it would float or it wouldn't float? It started with a D.
Density.
Buoyancy.
Very nice. Density as well. Good.
Of density.
So density is basically, it's telling you, it's really a comparison, actually, it's really a comparison of mass and volume, okay? So like, if you think about when people say, I'll give you an example. When people say, wow, she has really thick hair, okay? Well, you might have the same number of hair on your head as somebody else, but do you have a lot of hair in a very small space? So when you have something that's very dense, okay, I could have, actually, okay, for instance, these two mice are like the same size, okay? They take over the same amount of space, but this one feels heavier, it's denser, okay? They take up the same amount of space, but this one has more mass, so it's denser, okay? So if something takes up, it's like how much mass do you have in a certain space? That's what density is, okay? Let's see. So there's some other ones that I could talk about just in case. Anybody know what is called the technical term for when you see a metal and it's really shiny? We say it has something that starts with the L. Anybody remember that from like physical science?
Luster.
Very nice. Luster, very nice. All right. And then I don't have mine with me, but there's some other ones. I'm gonna write these, okay? They talked about these in the video. They're all properties of metals. Oh, this is going faster than I thought. Okay. One just means that I can take a metal and I can bend it. Like if you have If you have a face mask and it has a little piece of metal in there and you can bend across your nose, that means it's malleable. That's what that first one is, malleability, okay? And ductility just means you can draw it into a wire. So like all the stuff we plug in, like our cell phone chargers and stuff, they have wires in there. Well, it's copper, but they just kind of made it into a wire. All right, so those are physical properties. So let's see, let's try to at least get through chemical properties. Now, chemical properties are, if physical properties are things you can observe without changing the substance, chemical properties are things that you can observe, but you have to change it, okay? So these are, a lot of times you have to, we're just gonna say, do an experiment, okay? You're not necessarily, it doesn't have to be like a experiment, but say for instance, if I set something on fire, I'm pretty sure if I set this notepad on fire, it's probably gonna look a little different, okay? So these are things that do an experiment or things, how do I want to say this? I'm trying to think of the best way to say this. Let's say things you note, but the substance changes. Ignore that S. The substance, we'll say, does change. All right. Like for instance, and a lot of times it's stuff like flammability, right? If I take a sheet of paper and I set it on fire, I need to know, if I want to know that this is flammable, I would have to set it on fire, okay? If I want to know if this reacts with acid, I would have to put it in acid. And when I do that, it's going to change the paper. Like if I set this paper on fire, you're going to see smoke, you're going to see fire, you're going to get ashes. It's changing it. It's no longer going to be paper. It'll be some paper left, but it'll be a whole bunch of other stuff, okay? So some of those properties are, examples are
Flammability.
very nice. Flammability. Ooh, that F.
Reactivity.
Flammability. There's another one that sounds like, okay, guys, this is why I'm a science teacher. I don't know if I spelled that right. I don't know if it's 2 L's, 2 M's or 1, but whatever. Flammability, this is why I teach science. Flammability, and then the other one is combustibility.
Isn't one reactivity or something?
Yes, it is. Thank you very much. Combustibility, reactivity, and usually when we're talking about reactivity, a lot of times we're talking about with an acid. Okay, a lot of times we're talking about with an acid. So the difference between flammability and combustibility, a tree is combustible. If I go up and put a match to a tree, it will catch on fire. I may have to sit there for a little bit and do this number, but eventually it will catch on fire, okay? Flammability, if I get some gasoline and I put a match near it, it is gonna instantly ignite and it's gonna burn, okay? So that's the difference. Flammability is like easily ignitable. Combustibility is like, yes, it will burn. Reactivity with acid, like a lot of metals, if I poured acid on a metal, a lot of times it'll start like bubbling and looks like it's disappearing. That's reactivity with an acid. All right, so questions on this? Anyone still writing? Good. We got 2 minutes. I want to get through phase changes super, super fast. I know we can do this. Ready? All right, here we go. Okay, give me another one. Oh, here we go. All right, here we go. Super fast. So here are phase changes, and then we'll go back and talk about them more on Tuesday. Phase changes, okay? Phase changes, pH, are physical changes. And this is how you remember it. pH, pH, all right? Ooh, we got 1 minute. All right, let's try to get 2 of them down. All right, so here's the difference. We got solid, liquid, and gas. Let's see if we can get like 2 or 3 of them down. Phase changes are when you switch between solid, liquid, or gas. So solid to liquid, liquid to solid, gas to liquid, gas to solid, that kind of thing. All right, Tyson, if I put a bottle of water in the coldest part of my refrigerator, what is going to happen to it?
It's gonna start to freeze.
It is going to freeze. That is one of the freezing. That is one of the phase changes. Somebody tell me the opposite of freezing. If I leave chocolate in my car, it's going to
Melting.
melting. Very nice. Yesterday I had some Chick-fil-A. It was fantastic. And then when I touched my cup later on, my hand was wet. Why was the side of my cup was wet? But you might know what that's called. Starts with a C.
Condensation.
Very nice. Condensation. If I leave water in a pot and I come back and it has magically disappeared, what has it done?
Evaporated.
Very nice. Evaporation. And then I'm going to give you these last two, and then we'll talk about these on Tuesday. The last one, sorry, that E is struggling. All right. One is called sublimation. Sublimation. Another one is called, I'm going to try to write this, deposition. Deposition. Thank you guys for participating today. I will see you on Tuesday. Good job today. Thank you.
Bye-bye.
Bye.
Good
Thank you.
day. Have a good weekend too.
Thank you. You too. Have a great weekend. See you guys.
Thank you.
Good job today.